Good afternoon to all. Welcome back to my channel. Today we are going to solve the week 5 assignment 5 of cloud computing and distributed system. The last date is 26 February 2025. Okay. Now let's start. You can see guys here there are near about 10 questions. Okay. So we'll try to attempt the 10 questions one by one. Let's start the first question here with its explanations I will give you. Consider the given table of a agreement problems and match the correct pair. Okay, first is Byzantine agreement problems. It associated with single source has an initial value and all the non-faulty processes must agree on the same value. That is P to triple I. P to triple I. Okay, two options are there. Next is Q is consensus problem is associated with Q is 1. All the process have initial value and all non-faulty process must agree on the same single value. Okay, so it belongs to Q1. And last one is interactive consistency problems. Is all the process have initial value and all non-faulty process must agree on the same array of a value. So here you can choose option C. First explanation you can see here P triple I, P triple I, then Qi, then Qi, and then last one, interactive consistency R belongs to double I. R belongs to double I. So option C is the right answer. We just have to see the Byzantine agreement problems. This problem involves a single source that is a general essence value all process that is determinant and all the faulty process must agree on the same value even if some processes are faulty. Byzantine faults this match condition up to 3. So P or 3. Okay. Next, the consensus problems. All the processes have an initial value and all non-faulty processes must agree a single value. This matches condition I. That means Qi. Qi. Next, interactive consistency problem. In this problem, all the processes have initial value and all the non-faulty process must agree on the same array of value. That matches option 2. Matches option 2. Okay. Now moving to the question number 2. That is shown in that fully connected network, it is possible to reach an agreement number of processes exceed n minus 1 by 3, where n is the number of processors. So it is a which type of statement? This is a false statement. So to B, it is a false statement. This result actually states in that fully connected network agreement is possible only if the number of multiprocessors does not exceed this one. If exceeded this bound, the agreement cannot be reached. Therefore, this statement is false. So 2B is a false statement. Moving to the question number 3, once again true or false this statement or not? Byzantine agreement cannot be reached among 3 processor if one processor is faulty. If one processor is faulty, definitely is a true statement. We can argue here that true statement 3A. In Byzantine agreement problem, it is impossible to reach agreement among 3 processor if one of them is faulty. Okay, that's why it is a true statement because this is because the faulty processor can send conflicting information to the other 2 processor. Okay, it will make a problems that make it impossible them to agree on a single value. This is well known result in distributed systems. So this is a true statement. So 3 option A. Moving to the question number 4, consider the following statement. Statement 1. In synchronous system models, the synchronous is impossible to solve. And the second is in asynchronous system model, the consensus is solvable. Okay, last statement, Paxi provides safety and eventual liveness. May choose only 2 statement as here, only statement 3. Okay, you can see option 3, option, this is a 4 question. That's why this is Only statement 3 is true. We have to consider this statement. Statement 1, this is a false statement because in synchronous system, consensus is solvable because process can rely on the time and bounded message delays to the reach agreement. Statement 2, this is false statement. Also, this is a false statement. In asynchronous system, consensus is impossible to solve the presence of even a single fault, as proven by the FLP impossibility result. But the last one, statement 3, is true because Paxos is consensus algorithm that ensures safety, correctness, and eventual liveness in progress. It is a true statement. So by giving these explanations, we can choose only statement 3. Okay. But if you feel that it is only statement 2 and 3, you cannot. Moving to the question number 5, each step in a process takes bit less than timing is UP, where LB represents lower bound and UP represents upper bound. So, synchronous distributed system, question number 5B is the right answer. Synchronous distributed system. A synchronous distributed system is characterized by bounded message delay, bounded clock drift, and bounded processing time. These assumptions match the given conditions, make the synchronous model the correct choice. That's why I choose synchronous distributed systems, which is option B. Moving to the question number 6, go-down algorithm is uncoordinated checkpointing and a recovery technique that takes a consistent set of checkpointing and avoids domino effects and live-log problems during the recovery. We consider as a true statement because the co-stoic algorithm is indeed a uncoordinated checkpoints and recovery techniques that ensure that a consistent set of checkpoints is taken, avoiding the domino effect, and where the rollback causes cascade of a further rollback and a live problem where process are stuck in a roll of rollback. So it's considered as a true statement. That's why I choose our 6 option A. Moving to the question number 7, message whose send is done but receiver is undone due to rollback. What is that called? That is called orphan message. That is called orphan message. 7 option C. Orphan messages are messages that have been sent but not received due to a rollback. Message sent but is not be reached at the destination points. These messages are no longer relevant because the sender has rolled back to a previous state, making the message inconsistent with the current state of systems. That's why we choose option C. Moving to the question number 8, the cascaded rollback which caused the system to roll back to too far in a computations even to the beginning. A split of all the checkpoints is known as what is the that is called a 8. We can opt for domino effect. So what is 8C domino effect? So domino effect is occurs when a rollback is one process focuses other processes to rollback as well, potentially causing the system rollback to very beginning of the computation even checkpoints were taken. So 8C. Moving to the question number 9, message with receive recorded but message sent not recorded and do not arise if processes roll back to a consistency global state are called, these are called lost messages. This is which is 9B, lost SMS. 9B, the lost SMS are the messages have been received but their corresponding send event was not recorded. These messages do not arise if the process roll back to a consistency global state. That's why taken as lost message, which is option B. Then go to the last question. The dash many arises when a process rollbacks to its checkpoints after a failure and request all the other affected process also to roll back. Okay, so that is also you can treat it as a domino effect. 10C. The domino effect occurs when a process roll backs to a checkpoint and focus other process to roll back as well, potentially causing a cascade of roll backs through the systems. Okay. So 10 questions we attempted. Once again, try to verify the answer for the question. Question number 1, option C. Question number 2, option B. Question number 3, option A. Question number 4, option D. Okay, you may choose C also. But we do not want to take risks. That's a only statement 3. Okay. Question number 5, option B. Question number 6, option A. Question number 7, option orphan message. 87C. Question number 8, option C. Question number 9, option B. And last question number 10, option C. Now I'm going to submit the answer. Answer you have successfully submitted. Thank you for taking the assignment 5. Submission date is this much. Okay. Then we will try to put the answer of week 6 assignment 6 in my next video. If you have any comments or any correction or clarification, you just put in a comment box so that we people can interact and discuss. Okay. And if you happy, you may subscribe this channel and share with your friends and colleagues so that the other people can be benefited freely. Thank you for watching this video.